Hello, this is Tariq L1 presenting lecture number 5 of the SBM4104, the IT infrastructure. Within the last 3 lectures, we went over the OSA model, the 7 layers. As an overview, we cover each function, each layer function and services. And we start from layer number 1, the physical layer, then layer number 2, data link layer, then we move to the layer number 3, which is network layer. And we have mentioned that the main function and services which provide by the network layer is logical IP addressing and routing. Today we will cover the logical IP addressing. Last week we have covered basic concept about the IP version 4 and IP version 6. Today we will learn some type of subnetting, how to subnet. Very basic, very fundamental, how to allocate IP addresses for hosts. So, and next week we will cover the routing. So, what we will do today, we will go over the IP version 4 addresses, which we cover as well last week, but again, we will go over the schema structure, what the difference between network ID and network address, broadcast address, what is local, what is the problem with the IP version 4, which I mentioned the issue with the IP version 4 before. What's the problem? It's not enough. It's run out of it cannot cover the billions of devices we have currently and we need in the future as well. So what exactly again the IP version 4 addresses? Last week we mentioned that that is good. Last week we mentioned that the IP version 4 consists of 4 bytes or 4 octs as they call it. Each one can carry from 0 and up to 255, which is in total 8 bits. Those 8 bits, the total of those bits, if you actually put it as 1 and you convert this one, will give you a 255. So the first IP will be 0, the last IP will be 255. So how many total we have? 2 power 8 would give me 256 each. And we mentioned that the total number of this can be up to 4.3 billion IP addresses. Okay, so each one of here, so if we start as 0, 0, 0, 0, now I can start 01, 02, 03, 04, 05 like this until it becomes 255. Good. Then I change from here, this is 0, I make it 1 and start again from 0 until 255, then 2, from 0 to 255, 3, 255 like this. Keep going like that. When you finish that and this one reach 255 as well and become 255, and here up to 255 as well, we move over here, so 0, 255 like this. So this one 0, then become 1, then become 2, then become 3, then become 4, and each one it will go like that. So is that the concept? It's you can allocate IPs from 1 to 255. Yes, Usually we start from the left side, not the right side, sure. But the concept is you keep going from 0 until 255. One thing I would just want to mention to you that we have what we call it the network ID. What is the network ID exactly? Make sure to understand that. Usually in most cases, the first IP in the network, it becomes network ID. And the last IP in the network, that's broadcast. And I mentioned that before. So if, for example, if this is 1/24 or CIDR 24, so which means that this number will give me only 256. For example, if I go with 192.168, for example, that's 10.0/24 as a network. Alright, this 1/24, that means you tell me that this is a network. I cannot use that. That's only for network. So I have only 8 bits here for host, yes. So how many can I allocate over here? We mentioned before, still up here, 2 power 8, which is 256 IP addresses. How many host? Host means a device like a computer or server. I can use 256 minus 2. Why minus 2? Yes, because that IP, which is 0, that's gonna be the network ID, which means that you cannot use that. Okay, and the last one, which is 255, you cannot assign this one as well to a host. Why is that? Because that we call broadcast IP. What is broadcast IP exactly? If the network want to send a message or to broadcast to all the users, everybody, all the hosts, all the computer, all the devices in that network, you want to send one message to all of them, we call that broadcast, and that's one usually reserved, so you will not be able to use that. As you can see here, and which is we covered that as well, that's the format of the 4 bytes or the 4 octs. So the total, as we mentioned before, 4.3, almost sure 4.3 IP addresses. The network we covered before as well, break down into 2 sections. Any network, we break it down into 2 sections, one for host and one for network. Is that static? Last week we mentioned class A, class B, class C. If anybody still remember, class A, we have 1 byte for network and 3 for host. And this one we usually use the network 10. Class B, we mentioned, that's the famous one when we use for private IP. Sure, this one from 1 until the end of 126, as we mentioned. The famous IP, private IP, we use within that class, which is the 10. We have the B, the class B, as we mentioned, 128 until the end of 191. And this one as well, that's 2 for network and 2 for host. So 16 bits, 16 bits, like this one exactly, as you can see here, similar to that, 50-50. So 16 bits for network, 16 bits for host. You got to understand that the number of devices you can allocate based on the number of hosts. So for example, if you have a company which is has 200 employees, so how many I will need? I will need 8 bits only. That's gonna give me 256, more than 200, so it's enough for me. But if I have, for example, if I want, for example, more than 500, 700, whatever like that. So what to do exactly? Take another 8 bits. So the more host you need to take from the network piece. So if I have 200 only, no, I will take 3 for network and 1 for host. If I have more, I will take 2 for 2. If I have more and more, like thousands of devices, or hundreds of thousands of devices, I will take that which is 1 for network and 3 for host. So the more IPs, the more host addresses you need, which is based on the number of computer, of servers, of APs, of layer 3 switches, whatever it is you want to, or printer as well, you want to put IPs on. We will have an example of that, how to subnet 3-4 networks. So this is the IP version 4 addresses classes, and we covered that as well last week. However, we can cover that again. The class A, I told you before, as you can see over here, this is only 1 byte, which is 8 bits only, and here it is, and 3 bits for host. And that one usually, when we have any IP between start from 1 and end up 126. 127 usually reserved for testing. However, they include that in the within, but usually it end up with 126. 127 is a network by itself for testing or looping. However, okay, for now, just keep in mind that it is still as well as 127. The network, the class B has 16 network, 16 for host, and this one usually starts from 128 to the end of 191. Class C, as you can see, and the famous one with that class C, by the way, 192, 168. That's one of the really famous IPs we use, private IPs, 192.168.0.0 as well. And this one until the end of 223. Those one for multicasting, the D and the E, you will not deal with it at all, because that one usually reserved for multicasting and for future use. Okay, so for just to only practice, if you, I believe most of you should understand the concept of bits and bytes. So if you have, here it is, for example, this is like 1 byte, that's total of that exactly. If you change those into ones, it gives you the total of 255. So if I want to have 255, 255, 255, 255, that's the maximum I can get, and the lowest I can get 0.0.0.0. That's it. Yes, that's the maximum I can do as well. As you can see here, we give you just only an example of 191, 1.2.1, 2, as you can see here, 2.2, 2.3. What's that exactly? To understand, 192, 168.10.0. Okay, if this one is, for example, class C, so that's the network /24. What IPs I'm gonna get? .0, .1. Sure, all of it, 192.168, this is static one in all of them. So 10.0, .2, .3, .4, .5, .6 until you end up to 5. That's how it is? Yes. We will have another example on 17216, which is, for example, if I want to 17216, 10.1, 10.2, 10.3, 10.4, and over here, as you can see, we have 65,000 IP addresses. The first IP of the network, which is usually 0, that's the 0. This is the one, we call that the network address or address, and the last one we call it broadcast address. For example, this one to be considered, that 172.16.0.0 to be considered a network ID, and this one cannot be assigned to a host, to a computer or router or interface, nothing. That has to be reserved. And the network ID, the whole network, it become contained under that address. So when we ask you, for example, this is your subnet, yes, you have 10.1, 10.2, 10.3, 10.20, 10.50, 10.60, 10.70. So what is your network ID? 10.0. That's always like that. And this one, as we mentioned, that's the broadcast IP. Here, some example of the class A, class B, class C. As I told you, this is the real famous ones, and the 10.0.0, as you can see here, this is the network ID and this is the broadcast. That's the network ID 172.16, and this is the broadcast 192.168, and this one the broadcast. That's how it is? Yes, that's how it is usually in most cases. As the network 172 network is used as loop network. If you want to understand how, for example, 10.0.0 become like that, take 10.0.0.0. What you do exactly, I'm gonna take the first one, 10.1 dot what? Here it is, dot 1 or dot 0 first, dot 1, 0 dot 2, 0 dot 3, 0 dot 4, until this one reach 255. When this one reach 255, I'm gonna move over here and make this one 1. So it 1.0, 1.1, 1.2, 1.3, 1.4 until it reach 255. Make this one 2, 2.0, 2.1, 2, and so on. Keep going like that. And until this one become 255, you move over here, become 1, 0.1, like this. So where you start from? You start usually from the left side here. So you start from here and you keep going like that. 1.0.0 like that. 1, 2, 2.0.0. So what we usually exactly we do, we take, that's 10.0 for example. We keep this one as it is, and we took this one, the 0.0 for example, and we start taking this one. Keep this one as it is, none change, until you finish those. So this is the 0 dot until 255, 1 dot until 255, 2 dot until 255, until you reach over here 255.255. Then what? If I finish 255, 255, now you start do the same thing, but change this one into 1. So 1.0.0, 1 dot, like that, and it's gonna give you heaps of numbers. The zero network usually maybe has different meaning, but you can say that we don't use the zero network as a zero, like the 4 zeros. We don't use this one. You can consider it as as looping, routing. You can consider it as that. But in reality, we do not assign that to any subnetting or networking. This is what we mentioned before as well. We again, the class A. If you want class A, how many networks, not device, how many networks you can have? 2 power 7. The number of network, you can have up to 128 different network. How many network over here? You can have 16,000, 2 power 14, by the way. This is not 214, 2 power 14 to the exponential of 14. This one, 2 to the power of 21. So how many class C network I can allocate? Up to 221, power 221, which a lot of numbers. How many hosts I can allocate for each one? That's the issue. When you have class, as you can see over here, the number of bits reserved for host, this is the number. So for class C, for example, you have 8 bits only, so 256. This one 65,000 something, this one 2 power 24. What's the problem with the IP version 4? It's not enough. It's run out, and regardless of what we have done, subnet mask, VLSM, NAT, we have tried many things to keep it alive, but the number of devices currently in the market and in the future, IP version 4 will not be enough at all, especially with the new technology, with the home appliances and the cars and everything will have an IP address in the coming future. So the current IP addresses will not be enough. If you see something like a network diagram, you need to understand the difference between router, switch, hub, for example. At the beginning, we ask you that what's the router exactly? Its routing means you have a network, whatever your network is. For example, your company, let me give you, I have a company here. This is, for example, Epic College. This is Epic College. And we are here inside Epics with labs. This is lab number 1. This is lab number 2. This is lab number 3. Lab number 4. Okay, we have PCs here and we have plenty of PCs and printers and everything. Okay, how we communicate inside that? With the switches, different switches. So that lab usually has in the wall a switch here and all your cables running to the walls in somehow. Over here as well, over here as well, over here as well. And those switches usually link somehow as well with those switches as well usually link somehow through the walls by all those switches as well. They can talk to each other, the switches. All this, which is what we call it internal communication. So local, something like this, for example. That this one to be considered, that one, the whole thing like this, a network, whatever network 1. And the whole thing over here, sorry, the whole thing like here, like that, that's network 2. Really? Yes. So this is a network, this is another network. Alright, what else? How I know that I have a network? Any link between two routers represent a network. So that one represent another network, which is network number 3. Okay, so what are you talking about over here? These devices, like this PC, connect to the switch connect to another switch, so we can talk to each other. For example, this PC can talk to that PC through the switch, yes, and this PC as well can talk to over here to that PC and to the hub, yes, through the hub to the switch, yes, as well. So we can talk to each other here. Yep. Can the switch send my data to another network? Unless if it's layer 3 switch, it will not. Layer 2 switch like 2950, 2960, it will not. So what I need exactly, what we call it, we need a gateway. The gateway is usually a router. Usually as well, when we talk about the gateway interface, which is this one, that one. So when we're talking about gateway means if we want to communicate outside, this is network, this is my network, for example, this is the Epic College in, let's say, in Sydney CBD, and you want to communicate with Epic College, for example, as well in Central. This is Central. Okay, so you need to send your data to your switch. Your switch will send it to the main switch. The main switch will send it to your gateway. That router communicating from here to your internal network. The one you see over here, internal network. Now I need to go external network. So which usually it represented by the ISP provider. Okay, that's network. You go over here, as you can see, we send it outside. This is internal, this is external. According to that topology represents only 100 meter, which is still a network within a short distance. However, if you want to represent a WAN, you need another type of cable or network. However, the concept is what we try to explain to you here is you want to send data from your internal network to another network, you need to have some kind of routing device. The routing device, a router. That router, take it from here, send it routed to the shortest path, as we discovered before, the shortest path to network number 2, and from network number 2 it will arrive here, then it will arrive to the gateway, and from the gateway to here, to here, to here. So how many network we have here? 3 different network, 1, 2, and 3. Usually router separates networks. Again, routers separates network. Remember that. If you want separate routers, you separate it with, networks, you separate it with routers. Each router interface represent a subnet or network. Each router interface represent different type of network or different type of subnet network. For example, if I have a router like this for here, and I have interface here, fast Ethernet 00, and this one sure link to switch, and that switch has PCs and whatever. That's this one a network which has a subnetting and gateway, which is fast Ethernet. If we have another gig 00, for example, this is totally different network, and it has another gateway, and it has another devices and another switches. Remember that any interface, any router interface represent a different network. One more time, and the link between router represent another network. So if I ask you right now, how many network we have here? we have three different network. Network 1, network 2. Oh, okay, here it is, and this is network 3. Remember that. Okay, so how we assign IPs to the network. One thing, but away from your study, by the way, didn't have it been covered here. Why we have switch here and we have hub here? I mentioned to you before that the difference between switch and hub in very basic concept, that switch is a smart device, hub is a dumb device. Switch has what we call it multicast, hub has unicast. What does that mean, by the way? I just wanted to understand. With the hub, if the hub receive a message over here, it will send a copy to this and this. Really? So, but this message actually coming to that device, it doesn't matter. As far as like the hub receive a message, it duplicated to all the devices linked to. And if something happened with that device or the word this, whatever the port, if all the devices here will have problem linked to. The switch is different. The switch, I want send the data to that device. That data goes to that device only. Only. That's how it is. That's how it is. So if some problem happen here with that link, it affects that link only. And also this one has, we have what we call VLAN as well. We can put security on it. We can virtual LANs and many things. But for you, as a very basic concept, you need to understand that the difference between hub and switch. Hub is a dumb device, and switch is a smart device. How to assign IPs to different network? Very basic. If you have, for example, if you have for example, if I want to put hosts under 256, usually, as I told you, if I have 256 IP addresses, how many hosts I can use? -2, always subtract 2. So, for example, if I have an IP 192.168.10.0 and they told me I want 200 device here, very basic, very fundamental, no problem. Yes, I can use this one /24. /24 means I have only 1 byte. /24 means those 24 for the network. I cannot use 192.168.10. It's static. I will not be able to change that in the IP. So what I can change? Those ones. So what is the first? What is the network address? 10.0. What is the broadcast? The last one. What is the last one? 255. So here it is. This one can carry up to 2 power 8. Very basic and very fundamental. You know the total number of any IP address, 32 bits. We have 32 bits. If I reserve 24 for the network, I have 8 bits for the host. So I have 256. Okay. This is 200. Just very basic and very fundamental. This is 256 IP addresses. However, the first IP here is 0. The last IP here will be 255. I think we agree on that. That one I cannot use. That one I cannot use as a host. So this one is the network ID. This one is the broadcast IP address. And I have from 10.1 until 10.1 until 10.254 IP addresses. feel free to allocate any IPs. You need 200. Yes, you have over here 254. Allocate any IP addresses you like. Usually we prefer to use 123 until 200. That's how it's done, and that's it. And leave the from 201 until 254 for the future use or the future expansion. However, feel free to use anything between 1 to 254. That's if you want to have only 200, because 200 I can fit them over here. As you can see here. Alright, but what about if more than 500? What about if I more than 1000, for example, like this? What I can do exactly at that time, instead of taking one, just only one byte only, so start moving into take 2 bytes. Any big number. Ask yourself right away, if I want 200, can I fit them here in this one only? Yes. If I want 500, can I fit them here? No. If I cannot fit them here, what to do? Take the next one. So take both of them like this. Okay, can I fit 10,000 over here? Yes or no? Yes, yes, no. Move to the next one like that. Based on 2 power what? Give me 2 power what? Give me the number you want. Again, if I want, for example, 3000 device, usually add 2 in the top of that. So I need 3002. Ask yourself, 2 power what? Give me 3002. And whatever that number is, this is the number of bits you need. So if, for example, if assume you ask that this came as 10, 2 power 10, 2 power 10 or 2 power 12, for example, 2 power 12, that means the first one, it will not be enough, so I have to borrow the second one as well. We have another option, which is you can borrow the bit. So 12 I can borrow only 4, but away from your study. We call it VLSM. In your case here, if you want, take the whole byte. Don't worry about that. Okay, so let's go over that example, and I believe that you will find it's not that difficult to understand. I have here network number 1, 2, 3, 4, and as I told you, we have here, if I want to ask you how many network, total network, away from this case, if I ask you right now, we have 4 network here. However, how many actual network in this topology? Ask yourself and see how it goes. We have 1, 2, 3, 4, but we actually have another. This is number 5, this is number 6, this is number 7, this is number 8. That's how it is. That's what it should be when you actually do a real subnetting. However, since that away from your study for now, let's focus only on the piece which we for that to practice only. You have 4 network here, 1, 2, 3, 4. Those 4 networks. Network number 1 has 100 device. I told you when you have something like that, just add number 2, add 2 on the top. What is that 2? 1 for the network ID, 1 for the broadcast. However, the numbers here is easy and there is no issue. Sometimes in Cisco, sometimes they trick the people, for example. So what we have over here, for example, Cisco asks you, for example, we need 511 device. Really? Yes. So I need 511 device. If you ask for another 2, let me give you a small example. if you have 32, for example, if Cisco asks you for 30, we need 32 devices. So 32 devices give me 2 power 5, which is 5 bits only. However, the true, you need to add 2 here as well. So you need 34. To give you another symbol, if they told you that we need 256 device, what do you do exactly? Oh, that's very easy. We can take 1 byte. No, 1 byte at that time will not be enough. Why is that? Because you need, this is 256 device. I need a network ID. I need as well a broadcast number. So what does that mean? I need to add 2. So I need 258. This is one of the tricks in Cisco exams. However, in your case here, we give you a simple numbers only, but just only to understand as a concept, you need to add 2 in your head. 1 for the network ID, 1 for the broadcast. Here I need 100 PC. Here 50 PC. Network number 3, 500. Network number 4, 300. Okay, what you do exactly the first thing? Put them in the descending order. What do you mean by descending order? Go from like this. Put the highest number at the top, and over here 300, this is 100, this is 50. Okay, and now let's start with, I want 500. Let's go with very basic IP addresses. We'll take over here, if I want to go with 192.168.10.0/24. Can I fit this one? You said 24. So I cannot use that. I have only 1 byte only here to use that for host. Can I put 500 here? No, we can't. Which means that the /24 will not be good for us. So I need something to fit 500. Which one to fit 500? We need to borrow something from here. What to borrow exactly? Go to the next class. If this class C, for example, class C can give me 256. No, I don't want that. So let's go to the class B, which is 172.16. This one, the network, static, will not be changed. And here it is 0.0/16. That's it. Yep, I have here plenty of IPs which I can take. How to allocate that? Very basic and very fundamental. Okay, each one of these, look at this. Now I have 0.0. How many IPs I can put over here? We agree on that before. 256. Okay, so if I want to fit 500, how many of those I will need? I will need 2. So 256 plus 256 will give me 512. What to do exactly? Very basic and very fundamental. This is 0.0. It will finish here until 255. Does that make sense? So I have here 256 IP. Good. And I will change this one into 1. And this one will give me another 256. So very basic and very fundamental. I'm gonna go from here, from 0.0. Yes, if I went until 0.255, that will not be enough. That's 256 IP only. So I need another one. What is the other one? 1.0 as well. So 0.0 and 1.0. This one will give me 256. This one will give me 256. That's more than I need, which is good. So where I'm gonna start here, I'm gonna start with 0.0 as an IP, and where I'm gonna end 1.255. That's the broadcast. That's broadcast, and this is the network ID. Where is my valid IP addresses, which you can assign it to those 500? Anything between, all the number between those ones, this is your number, this is host number. So between 00 and 1.255. That's how it is? Yes. So, okay. What about the next one? Very basic. Where I finish here, I took 0.0 and I took 1.0. What's next? 2.0. 2.0. It's gonna give me until 255. Can I fit this 300? No. So what I'm gonna go? I'm gonna take the next one. 3.0. That's it? Yes. So I'm gonna start my network ID here, 2.0, and my broadcast 3.255. This is my broadcast, this is my network ID. Where is my host? Here it is. Between those one, any number you like between 2.1 until 3.254. Finish with that? Yes. Let's go. I need to put 100. I think 100 is really easy one. 100, that's a very basic one. So this is 4. I choose 2.0 and I finish 3.0 as well. So let's go over here with 4.0. Okay, 4.0. Can I fit 100? Yes. Now this one I can fit 100. So what is my network ID? 4.0. What is my broadcast? 4.255. And what is the between over here? From 4.1 until 4.254. The 50, I think that's become easier. 5.0 and until 255, the whole block. 5.0, 5.255, any IP between both those ones from 5.1 until 5.254, it's all yours. And what IP I can use? You can use. Usually in your lecture, we try to use between 1 to 100. Between 1 to 50, but that has to be, is not, it doesn't. As far as like you allocate 254 IP, feel free to use any one of those. Let's go over the subnetting over here, and I'm gonna show you how that works. For example, over here we're gonna use the 172.16.00. I need over here 500. Okay, so what to do exactly? I'm gonna take 172.16 as a network ID. So 170.16, it's gonna be static for us. It will not be changed. What will be changed? This ones. Alright, so now I'm in the network 0.0. Good. This is, here it is, static as here, not static, but for now. Now 0.0, what is the first IP? 0.1, 0.2, 0.3, 0.4, 0.5, 0.254, and then it finish up to 0.255. Do I have 0.256? We don't. Do I have 0.257? We don't. If I reach here and I haven't finished my 500 numbers, where to go? To the next one. So I finish here is 0. What to do exactly? Move to the 1, as you can see here. Since I finished over here all the bits which is allocated by 1 byte, which is this one, I finished those ones. So I'm gonna move 1.0, 1.1, 1.3, 1.4, 1.5, 1.6 until to reach 254, and then the broadcast 1.255. That's how it is. That's very basic and very fundamental. Even you don't need to stop by 46, for example, dot 1.46 or something. No. Any IP over here, you can allocate it to your host for now. So I have here, since I have taken the 0 byte, which can give me 256, and the 1 byte, which can give me another 256, that means 512. Subtract from them the two, one for the network ID, which is this one, and one for the broadcast over here. You have 510 IP addresses valid for host IP addresses. You can, now you need 500, take 510. This is the network ID, the broadcast, the valid host from 0.1 until 1. Watch this one. This is from 0.1 until 1.254, and 172.16 as it is. And the gateway, this is the first IP usually. The first IP we prefer, by the way. It doesn't have to be. The gateway doesn't have to be the first IP, but we prefer in our configuration to be the first IP. The next one, we can move to the same concept. Since I used 0 and 1, I'm gonna use number 2 here, 2.0, 2.1, 2.2, 2.1 until here. Can I fit the 300? I want 300, is not. So I'm gonna move to 3.0, 3.1, 3. Until 4, 5, 6, 7, 8, until to reach 3.254. This is your last valid IP, host IP. And this one, the broadcast. This is the 300, 2.6, 2.0 until 355, 2.1 until 3.254. You need 300 only. We allocate you up here 510. So you have 210 IP extra for future use. 4.0, 4.1, 4.2. Here I just need 100. That's an easy one. So can I fit 100 within the 4 network? Yes, I can, because this one will give me 256. So I don't need to go to 5, for example, for this network. That's 4.0, 4.1, 4.2 until 400. This is, you can go from 1 to 100. However, you have from 101 until 254 still reserved for future use. And over here, the broadcast addresses. That's the 100, 4.0, that's the broadcast, the last. This is the first IP, the first host IP, the first host IP. It doesn't have to be the gateway, the first host IP, but we prefer that. And that's the valid IP you can use. As you can see here, you can start from 4.1 until 4.254. Do I need all of them? No, I need 100 only. So you can start from 1 and you end up with 100. What about the rest? It's reserved for future use. Over here we have only a 50. I believe that's very basic. That's 5.0 network, 5.1, 5 here. This is the last thing you need. All these as well reserved for future, and the broadcast 255. As you can see over here, that's 5.1, the last IP, host IP 254, the gateway 5.1. I need 50 only, so I can use from 1 until 50. What about from 51 until 254? Reserve. We have a way which you call VLSM to allocate those IP together, but this is totally away from your study. So I can allocate 100 and I can allocate the 50, for example, in one network or in one CIDR. We use the same network but different CIDR or different slash. For example, one of them will be slash 26, the other slash will be 27, for example, or the other slash will be 28. However, the VLSM totally away from your studies. For you need to just only go with those basic concept, which is allocate blocks out of 256 IP. This is the final allocation, as you can see over here. Network 1 from here, as you can see, from network 3 we'll start with that. That's because this is the 500. We're gonna start from 0 until 1, from the end of 1, from 2 until the end of 3, as you can see here. This is 4 until the end of 4. This is 5 until the end of 5. We give you that network, which I'm gonna give you the hint for that. You need 200, 250, 75. Up to here, there is no problem. The only thing over here, when you try to allocate these two IP, by the way, when you have, just make sure to understand that this is a network. That network, you need a network ID and broadcast. Make sense? That makes sense. So, and I need an IP address for this interface, and I need an IP for this interface, which means that I need a total IPs of 4 IP addresses. So when you see something linked like that between 2 routers, you need 4 IP addresses, not just 2. The 2 IP addresses here and here. But you need a network ID. For example, 192.168.20.0. I'm not gonna say 30. For example, sometimes we use the 30, but for now, let's take it from here. So this is slash 24, for example. That's a lot of wasting IPs, but for the sake of this lecture only, take it like that. So what is my network? 20.0. What is my broadcast? 255. I have from 21 until 25.4 to put them here. Put any IP here, whatever you like here. However, the network here 20.0, the broadcast here 255. Do not forget that. That's the summary for today. Try to practice on that example. I have put you online as well on the Canvas few videos about subnetting. Just watch those ones as well. Come back to me with any question you like. I'll be more than happy to help. Have a good day, and if you have any question, feel free to email me.